Large language models, or LLMs, are transforming AI. They understand and generate human-like text, revolutionizing our interaction with machines, powering chatbots, translation, and content creation. LLMs are reshaping industries, a testament to machine learning progress, trained on massive datasets, learning patterns and relationships, deep understanding of human language, performing a variety of tasks, driven by vast amounts of data, no shortage of training material. From books, articles, websites, and more. Comprehensive understanding of language, computationally intensive training requires significant processing power. Results are worth the effort. Generating high-quality text, translating accurately, answering questions, indispensable in various domains. Building a successful LLM begins with a strong foundation, high-quality data. This data, collected from diverse sources like books, articles, and websites, forms the basis of the model's understanding of language. Just as a house needs a strong foundation, an LLM requires a robust and diverse dataset. The emphasis on quality over quantity cannot be overstated. While large datasets are important, the quality of that data is paramount. Data that is irrelevant, inaccurate, or biased can negatively impact the LLM's performance. Imagine teaching a child to speak using only slang and colloquialisms. Their grasp of formal language would be limited. Therefore, data preprocessing is crucial. This involves cleaning the data to remove errors and inconsistencies. It also includes formatting the data in a way that the LLM can understand. This might involve tokenization, which breaks down text into individual words or subwords. Another important step is removing stop words, which are common words like the or a that don't carry much meaning. Training an LLM is a computationally demanding task. It requires specialized hardware capable of handling massive amounts of data and performing complex calculations. This is where graphics processing units, or GPUs, and tensor processing units, or TPUs, come in. These specialized processors are designed for the parallel processing required in machine learning. GPUs, originally designed for graphics rendering, excel at handling the matrix multiplications central to LLM training. TPUs, specifically designed for machine learning, offer even greater computational power. They are optimized for the tensor operations that form the building blocks of neural networks. However, even with powerful hardware, training an LLM can take days, weeks, or even months. This process involves feeding the model massive amounts of data and adjusting its internal parameters to minimize errors. It's kind of like teaching a child to ride a bike. It takes time, patience, and constant adjustments. To improve efficiency, various optimization techniques are employed. Quantization reduces the precision of numerical values within the model, making it smaller and faster. Pruning eliminates less important connections in the model, streamlining its structure. Distillation involves training a smaller student model to mimic the behavior of a larger teacher model, resulting in a more compact and efficient model. Once an LLM is trained, it needs to be deployed in a way that makes it accessible to users. There are several deployment strategies, each with its own benefits. Cloud-based deployment offers scalability and flexibility, allowing users to access the LLM via the internet. APIs, or application programming interfaces, provide a standardized way for other applications to interact with the LLM. For organizations with specific privacy or security concerns, on-premise deployment might be preferable. This involves running the LLM on local servers, giving the organization greater control over its data. Another emerging trend is edge deployment, which involves running the LLM on devices like smartphones or IoT devices. This reduces latency and allows for offline functionality. The choice of deployment strategy depends on factors such as cost, performance requirements, and security considerations. As LLMs become more sophisticated and their applications more diverse, we can expect to see even more innovative deployment strategies emerge.